Hi and welcome to the Mechanics of Healing. This is part 1I, and today's topic continues our series about the digestive system. The digestive system is one of the most important, if not the most important system in the body, so it's important to know how it works. When we deal with the healing of the body section, we will discover how the brain and the stomach work together in healing the body. They are made of the same basic material, so when the brain surgeon temporarily removes a part of the brain in order to keep it alive, they sew it to the lining of the stomach. And this piece of information is priceless that will become clearer in later topics. We have to remember that digestion begins with chewing our food properly. When we chew our foods, our mouth releases saliva that has small enzymes in it that makes the food more easily digestible. The process is also called flexurizing. We will hear more about this when we deal with staying healthy and healing the body. Thank you for watching, and be sure to watch the next part 1J.
You know, we've been talking about a lot of serious stuff here lately. Heart failure, respiratory, gas exchange, people with holes in their stomachs, nachos. Some might even say that I've been flaunting my ability to eat, digest, and enjoy a plate of chips and melted cheese. And I wouldn't blame them if they did, because sadly, nachos aren't for everyone. In fact, I can safely say that nachos are really only a good idea for about 1/3 of humans. For the rest, what may start as a party in your mouth will surely end in gastric distress. Such is the fate of the lactose intolerant. Lactose is basically milk sugar that can only be digested with the help of a special intestinal enzyme, lactase, which many adults do not produce enough of. In fact, way back in the day, none of us did, until about 7,500 years ago, when a particularly handy genetic mutation popped up in Central Europe. This so-called lactase persistence trait probably spread as Neolithic groups trekked north and west through Europe. Today, nearly 90% of adult Britons and Scandinavians can chug all the milk they want, whereas down toward the Mediterranean, probably less than 40% have lactase persistence, and fewer than 10% in Africa and Asia. Now technically, a lactose-intolerant person can still consume dairy at their own risk, but since their own bodies can't break down lactose, the job is left to the 3-pound bacteria farm living in their large intestines. Bacteria that try their hardest to make something of those milk sugars, the results of which are gas and bloating and diarrhea. So it turns out, nachos aren't just a good way to talk about how the digestive system works, they're also a good way to talk about what happens when it doesn't. Remember how the stomach is great at obliterating matter, but not so hot when it comes to actually chemically digesting stuff or really absorbing much of anything? You might say the stomach lacks subtlety, but luckily it's got friends in low places, and the small intestine is more than happy to pick up the slack and provide a cozy environment where your food is at long last disassembled and absorbed by your cells. Now there's a lot of mechanical action and peristalsis going on here, but there's also a ton of chemical digesting too. And while homebrewed intestinal juices help digest the chyme that your stomach turns food into, the real power actually comes from the outside helpers, the liver, gallbladder, and pancreas. Now the small intestine is called small, not because it's short, but because it's about half the diameter of the large intestine. The thing is actually like 6 or 7 meters long. Not only that, but the whole thing is lined with epithelial tissue that has more folds than an origami octopus. These folds are lined with tiny hair-like villi, and even tinier microvilli, which create a truly impressive surface area, large enough that if it were unfolded it would cover a tennis court. It's this massive surface area and the countless capillaries just beneath it that make the small intestine such a champion absorber of nutrients. It shares the same 4 tissue layers seen throughout the GI tract and has 3 main subdivisions. Straight out of the stomach and snuggled around the pancreas, you've got the relatively short and mostly immovable duodenum, which is where most of the chemical digestion occurs. The middle section is the jejunum, where most of the absorption takes place. And finally, at the end, running into the large intestine, is the ileum, where important important vitamins like A, B12, E, D, and K are absorbed. But the duodenum is what you might call the business end of the small intestine. It receives chyme and gastric juices from the stomach through the pyloric sphincter, but it also imports bile from the liver and gallbladder, enzymes from the pancreas, and it creates its own homegrown mix of enzymes. Some of the imported enzymes eventually pass through your system on the wave of gooey chyme, but other enzymes are actually bound to cell membranes in the intestinal mucosal layer, and they're reusable. Enzymes are proteins, and proteins are expensive, so these compounds, known as brush border enzymes, can just sit around and process food as it passes by without your body having to make new ones. And the lactase that so many of us don't have is one of these. Now, the duodenum communicates with the stomach in the last phase of gastric regulation, which we talked about in the last episode, the intestinal phase. This is where the duodenum lets the stomach know, with hormones and nerve signals, when and how much chyme to release so it doesn't get overwhelmed all at once. It's also where stuff like bicarbonate from the pancreas gets dumped to help neutralize the stomach acid before it burns a hole in your guts. And this brings me to your crucial accessory organs, the things apart from the alimentary canal that never come in contact with ingested material, but still play an essential role in digestion. First up, the liver. The liver is a massive, fatty, four-lobed, and very important organ. It lives directly under your diaphragm, and fun fact, it can actually fully regenerate itself after an injury or surgery with as little as 25% of its original tissue. The liver serves tons of critical metabolic and regulatory roles that we don't have time to get into right now, but its main role in the digestive system is to make bile. Bile is the missing ingredient your body needs to attack fatty foods, which is a tricky business. In part, that's because fat isn't water-soluble, and since your insides are mostly water, fats will clump together, becoming hard to digest. To keep fat from clumping, you need an emulsifier, so bile comes in to keep big hydrophobic fat molecules from sticking together, which allows lipid-hungry enzymes to move in and break them down into fatty acids and monoglycerides that you can then digest and absorb. But while your liver creates the bile, it gets stored and concentrated in the neighboring gallbladder, the thin, green sac cozied up to the liver. It gets the signal when chyme slides into the duodenum, which activates the enteroendocrine cells to release a pair of hormones. Those hormones in turn tell the gallbladder to contract and squirt bile through the cystic and bile ducts into the duodenum. Another crucial accessory organ is the pancreas, a gland that looks like a fistful of cottage cheese stuffed in a plastic bag. The pancreas also does lots of important things for your body, especially related to your endocrine system, but for our purposes today, just know that it brews up a powerful enzyme cocktail that is also triggered by those same two hormones. Pancreatic juice is kind of like the Neapolitan ice cream of bodily secretions. It's like everybody's favorite ingredients all put together, and when you mix them, the result is especially powerful. You got trypsin and peptidase in there, which break proteins down into amino acids, and you have lipases that turn triglycerides into fatty acids and glycerol. Amylase, meanwhile, reduces carbs to glucose and fructose, and nuclease busts the nucleic acids that are in DNA and RNA into nucleotides. Once all those macromolecules have been disassembled into their monomers, the small intestine's epithelial cells can finally absorb and transport them through your capillaries and into the bloodstream, where they can travel pretty much to any cell in your body and be used to build collagen or store fat or replace dying cells. The final and true purpose behind all of that eating that you do. So, once the chyme has worked through your small intestine, it passes through the ileocecal valve and hits the cecum, the first part of the large intestine, where, congratulations, your food is now officially feces. The large intestine, consisting of the colon, rectum, and anus, is relatively short, at about 1.5 meters, and it provides a nice little frame for the small intestine here at the end of the alimentary canal. By now, your body has sucked up almost all of the nutrients it can and is basically just pushing indigestible goo around, so the large intestine doesn't have a lot of hard work to do. Its main functions are to absorb any remaining water so you don't have constant diarrhea, and to store the rest until it's ready to exit the body. It also plays host to hundreds of species and trillions of individual gut bacteria, which digest whatever chyme your body couldn't, releasing essential B and K vitamins and some short fatty acids, which the large intestine can still absorb. In doing so, they also produce gases like carbon dioxide and methane and sulfurous compounds called mercaptans and hydrogen sulfide, which eventually pass. Okay, I know what you're thinking now. You're like, Hank, what's up with the nachos? Surely you're not just gonna bring up nachos at the beginning of the episode without explaining how they can turn on you. Well, I've never disappointed you before, have I? Those of us who can't produce the enzyme lactase in our small intestine simply let milk and cheese pass through the organ untouched, leaving the digestion to those bacteria in the large intestine. And those bacteria possess about 1,000 different kinds of enzymes of their own, including lactase. But their digestion process produces a whole lot of extra gas, which is why nachos may leave me feeling cheesy and satisfied, but leave you bloated and crampy and malodorous. But enough farting around. Let's wrap up this fantastic journey. Fecal matter keeps moving through in a couple of different ways. Slow segmenting haustral contractions keep mixing and chopping it in the large intestine, occurring every 30 minutes or so and lasting about a minute. But most people also experience a few mass peristalsis movements a day, big, intense contractions that clear out a large swath of intestine at once, pushing feces into the rectum. These often occur just after eating. Once in the rectum, your poop stimulates stretch receptors that tap the parasympathetic defecation reflex, which signals the colon and rectum to contract and the internal anal sphincter to relax. This forces the poop into the anal canal, sending more messages to the brain that allow us to decide whether to voluntarily open the external anal sphincter or just hold it for a minute while we find a bathroom. And when that moment arrives, what was once food says farewell to the alimentary canal that temporarily held it and passes back into the light of day. And that, my friends, is the end of your digestive system. Pretty cool, right? And so it's all over, but that doesn't mean you should forget about what we learned today, which is that the small intestine performs most of your chemical digestion in the duodenum, while accessory organs, including the liver, gallbladder, and pancreas, contribute enzymes that all but finish the job. Then, your large intestine, which is actually shorter than the small intestine, tries to extract the last bit of nutrition, including the occasional attempt to turn nachos into energy, which for most humans ends in gassy failure. Thank you to all of our Patreon patrons who help make Crash Course possible, not only for themselves, but for everyone through their monthly contributions. If you like Crash Course and want to help us keep making videos like this one, go to patreon.com/Crash Course. This episode was filmed in the Dr. Cheryl C. Kinney Crash Course studio. It was written by Kathleen Yale, edited by Blake DiPestino, and our consultant is Dr. Brandon Jackson. It was directed by Nicholas Jenkins, edited by Nicole Sweeney, our sound designer is Michael Aranda, and the graphics team is Thought Cafe.